So it makes sense that the carbonyl compounds. You guys want to go over them? Remember the four, what they are?
Yes.
What's number one?
Substitution?
Okay, so what are carbonyl compounds? Carbonyl compounds. What's a carbonyl group? Okay, yeah, so a C double bond O is a carbonyl group, right? So this is a carbonyl carbon, that's a carbonyl oxygen, right? You're going to have some sort of R group attached to that. And on this side, you can have different things. What can you have? You can either have another R group.
And hydrogen.
You can have either a halogen. You can have, what else can you have?
Hydrogen.
You can have a hydrogen. What else can you have?
And
There's a bunch of them. Yeah, so you can have,
CN.
what do we call this?
hydrogen. Amine.
Amine.
Yeah, so this is an amide. So amide,
Aldehyde.
aldehyde,
Ketone.
لا.
Amine.
acid halide, right?
Alkyl.
Acid halide.
Alkyl.
Acid halide, that is a ketone, good. And what else can you have?
Sulfide.
The main one that's a derivative.
Carboxylic acid.
Yeah, you can have a carboxylic acid.
Aldehyde.
And someone said another one. What was it?
Sulfide.
Say again?
Sulfide.
A sulfide? What's a sulfide?
Oh, okay. That's double.
Sulfide is R,
Between.
S, R, right?
So,
That's a sulfide.
sulfuric.
Sulfide is like an ether.
Theo.
A thio.
Carboxylic acid.
Fine.
Carboxylic acid here.
Ester.
An ester, good.
يعني عم تبدأ الجروب.
Yeah, so these are all compounds that contain carbonyl compounds, right? These are all carbonyl compounds. They have a carbonyl group in them, okay? And remember, if you guys remember when I talked to you about these, they're split into two major groups. What are the two main groups of carbonyl compounds?
Aldehyde.
Aldehydes and
Uh,
ketones are one group, group number one.
group number-
And the rest of them, everything else is group number two. So when you want to think about the reactions that these guys undergo, we can actually say two of the reactions are specific to these two groups, and the other two happen everywhere else. What's reaction number one that's specific to aldehydes and ketones? Someone said it.
Nucleophile substitution.
A nucleophilic addition.
Okay, خلاص.
Nucleophilic addition reaction, okay? So this one is specific to groups one, only aldehydes and ketones. What do the carboxylic acids and their derivatives undergo? What do we call that? So if they reacted with a nucleophile, what would happen?
Acyl. Acyl.
Yeah, so an acyl what?
Substitution.
Acyl substitution, yeah. So substitution. So basically, if I had a carboxylic acid and I reacted it with something like, well, no, our carboxylic acid is not a good one. Let's go with one of these, and I reacted it with a nucleophile like OH minus. I would basically convert this to a carboxylic acid because of this reaction. Okay, so that's an acyl substitution. The acyl group, you get a substitution on the acyl group. This thing is called an acyl group. No, wait, well, this thing is called an acyl group. Okay, so you're substituting the halogen for an OH in this case. Okay? So reaction number two is only specific to carboxylic acids and their derivatives. The two other reactions that we know are basically, they work on all the other, on everything. Anything that has a carbonyl compound has these reactions. So what's reaction number three? You guys remember?
Alpha substitution?
Yeah, so alpha, what's alpha substitution?
The size carbon.
Yeah, so basically each of these, if you look at them, this R group here is some sort of carbon and then maybe another chain or whatever. This carbon here is called the alpha carbon, and the alpha carbon has hydrogens on it, right? And these hydrogens basically get substituted with specifically an electrophilic. So something that's an electrophile, not a nucleophile, is going to substitute over there, okay? So that's reaction. And reaction number four? You guys remember? It's all in that chapter. Metalathmus, there's no more. The last one has to do with kind of like an alpha substitution, but let's say you have two of these. right? Two of these or two of these. They can combine together in a condensation reaction, right? Condensation reaction. Okay. So if you look at that chapter that has those four things, look at them. And just know, you don't have to know the mechanisms, but just know what happens when you get the reaction. Yes?
One and two are only for the ketone and the aldehyde.
One is only for aldehydes and ketones.
The rest,
Two is only for carboxylic acid and derivatives. And these work on all of them. All of them can undergo that. Okay? هلا the way the questions are written, okay, الطريقة اللي كتبوا الأسئلة, they made it simple. They actually tell you what the reaction is.
name.
They'll tell you, like for example, like it'll tell you, I'll give you an example. For example, it'll give you an aldehyde and it'll say, name the product from the following nucleophilic addition reaction. It'll tell you that. It'll tell you it's a nucleophilic addition reaction. It will give you the aldehyde or the ketone, and it will give you what the nucleophile is. So all you have to know is what would look, so let's look at an example.
So doctor, the question will be naming or what's the product?
The product. In some cases they might ask you to name. Okay, but you have to know how to name anyway, so don't worry about naming. Okay, so let's look at an example. Let's look at here. Let's look at it. So okay, so hang on. Let me go over the reactions and then we'll do some examples, all right? So know those four reactions that I told you about, okay? The ones that we just talked about there. Do you remember the alkene reactions? You remember these guys? You remember that you had this molecule and you could react everything with it? So know how to do the Br2 reaction or the Br2H2O reaction. So know this one.
This is question 3.
This is still part of question 2.
Question two.
Remember, question 2 has 5 reactions. I'm telling you what reactions to learn. Okay? So either this or this. Which you two here.
Yeah,
Okay.
two
Or
or
Br2H2O. Okay? So what's the result of a Br2?
Trans.
trans.
Trans bromine bromine, right? You're gonna get a bromine here and a bromine here, right? On opposite sides. If this is the top, this becomes the bottom. And here you'll have a hydrogen, right? And you'll lose a double bond. So that's what happened with bromine. What happens with Br2H2O?
Cis or trans.
Alcohol.
Alcohol.
Yeah, so only an alcohol?
BR and alcohol.
Br and alcohol. And are they cis or trans?
Trans.
And where does the alcohol go? Yeah, so know these ones, okay? So know Br2 and Br2H2O. It's in your notes. Make sure you know these two. Okay, so I'm gonna put them here again. 1, Br2, 2, Br2H2O, okay? Know this know one of these two. One of these two you're gonna see on the exam.
Second.
That's how easy I'm making this for you. What else do we have to know? We have to know still the acyl substance. Okay, you remember the chapter on aromatic compounds? Chapter 15 and 16? Okay, so chapter 16 had substitution reactions. Either halogens substituting on the ring. Remember that? So if you have a ring, like an aromatic ring, right? So we have this guy, right? Well, what happens if you react this guy with, I don't know, HCl or something? What would happen? Would you break this bond?
No, it will not.
What would you get? This is chapter 16. Chapter 16. Okay? So what would you get? What's the result of this reaction? If this was an alkene, if this was an alkene,
Okay.
if this is what we were doing here, right? We get a chlorine and a hydrogen adding to each way in a Markovnikov way, right? So the hydrogen will go to the carbon that has the most hydrogens. So you get this, right? You get a hydrogen here, right? Let's use the and you get here you would get the Cl, right? So that's what you get in this case. What happens in this case? So if I said, what is the product of the following aromatic substitution reaction? What do you think would happen?
It will not proceed because the
Will proceed, but what would happen? So, aromatic substitution. What does substitution mean?
change.
Yeah, so what we have here that can be substituted?
Double bond.
Yeah, we got these hydrogens, right?
We can add it anyway.
Yeah, exactly. So the result you would get is
دكتور.
Did I forget my keys here?
keys.
Yeah.
I'm not sure. Where would you have put them?
It should be here.
Yeah.
Oh, I did.
Yeah, I didn't see.
You
them.
didn't see any keys?
No, I didn't see any keys.
Okay.
I'll keep an eye out for them.
Okay, thanks.
Yeah.
Okay, thanks.
تحت الوضع.
All right. So back to this. Okay. So what I'm trying to say is the questions will tell you what the reaction is. So it will say, for example, what is the product of this aromatic substitution reaction? So substitution means something is going to be flipping, right? So if you look at this, originally it had hydrogens. Your reaction is going to be this chlorine is going to basically substitute on any one of these hydrogens. That's what a substitution is. Okay?
So how can I write the answer?
Say again.
How can I write the answer?
The answer, you would draw this. You would just draw this. That's it. That's the
Without
you
the
don't have to draw the hydrogens. The hydrogens are assumed, right? So you
Anywhere, I'll just one.
just add one of them, yeah, just the chlorine, for example, in this case. What if it had something on it? What if it looked like this? Then what would it look like? How many products would you get in this case? Here you're only going to get one product before. What if it looked like this? How many products would you get?
We got
Three.
Yeah, so you can get it here. So if we put this original guy here, you can either get the chlorine here, that's one product.
P or
You can get the product here, or you get the product here. So it can either be M,
P or O.
Sorry, O, M, or P. Okay? So you just know that. So when it says aromatic substitution, know that it means an aromatic substitution. Everyone's okay so far? The other part of chapter 16 that you should really know are the Friedel-Crafts reactions, the acylation reactions. You guys remember those? So that's where, look at your notes. So it's chapter 16. You want me to tell you the exact section?
What, doctor? Question 2 still?
We're still question 2. This is I'm telling you what reactions to focus on, okay? So the 4 reactions we talked about, this alkene reaction with either Br2 or Br2H2O, and all the reactions in chapter 16, the substitution reactions and the Friedel-Crafts reactions, okay? So these are the acylation reactions. So let's pull up chapter 16 and I'll show you what I'm talking about. Lecture notes. Let me just duplicate the screen. So this is my screen. This is your stuff in chapter 16. No, this is chapter. We need chapter 16, sorry.
Doctor,
No, that's both of them. Yeah.
and question 2 for the reactions, do we have to name the product?
In some cases, they'll say name the product. So you should be able to name it. Like you'll say, oh, this or and this. Yeah. It's not going to be anything you shouldn't be able to name. And by the way, I'm going to be nice, guys. If you mess up, as long as you don't completely mess it up. If you give me the product and it's somewhat wrong, but you name it correctly, I'll still give you the marks for naming it correctly. That being said, don't draw a random structure and name it for me. Okay? Don't just draw methane and say, oh, it's methane. Okay? You won't get any marks for that. It has to be close to being correct. If it's completely wrong, you won't get any marks for it. Okay? So as long as it looks like something like the answer, even if you mess it up, but you name it correctly, I'll give you partial marks. Okay? So don't give up on the naming if you don't think it's Alright. Yeah, nobody draw a water molecule and say it's water, for example, alright? You won't get any marks for that. Okay, so this is what I'm talking about. So these are the aromatic substitutions, right? Where you get basically substitutions on the ring. Or the other one that we want to know about is, don't worry about, I'll tell you not to worry, don't worry about these weird ones, these nitrifications and all that. Just know these ones, halogen, like adding a halogen to a ring or substituting a halogen in a ring, and know the Friedel-Crafts acylation. Okay, this reaction you should definitely know.
Only two from chapter 6, right?
From chapter 6. All right. Yeah, the Friedel-Crafts reaction. Okay. So you should know these, including knowing when you get rearranged. Remember that what's one of the limitations of Friedel-Crafts is you can get rearrangements, right? So depend because you're always going to form the mechanism always involves forming a carbocation. So you remember this? Remember one of the limitations is you can get skeletal rearrangement because you're forming a carbocation, right? So you can get either hydride shift or methyl shift. One of the two things will happen, and you'll get a more stable carbocation. So know everything there is to know about these Friedel-Crafts reactions, so you can actually solve the question you get. Any questions on it? All right. So now that being said, let's go back to this. Okay, now we're going to go into question 3. Question 3 is worth 20 marks, and it is a 3-parter. Part 1 basically is going to tell you, it's going to tell you about a reaction mechanism, specifically how to build an ether. You guys remember how to construct ethers? The most well-known method of constructing ether is the Williamson ether synthesis method, okay? So it will tell you that this is the method you use to construct an ether. It will tell you what the mechanism is. It'll say in points what the mechanisms of that is. And then it will ask you a question. How do you build, if you have these two reactants, what is the ether you will get from that synthesis? And it will tell you to show the mechanism of that reaction. But you should know, you don't memorize the mechanism because it'll tell you what the mechanism is. Just make sure you understand. So the Friedel-Crafts reaction is one you have to know. Also know the Williamson ether synthesis method. You want to know what chapter that is? Or is it? Okay. That is in chapter, it's the one on alcohols and ethers. So it's, would be, let me just make sure. That's carboxylic acids. Chapter 19 is aldehydes and ketones. It'll be either chapter 17 or 18. These two.
هل هو تصور خلاص؟
آخر شيء نسأله شيء. نسأله إذا درست الأشياء خلاص.
It's chapter 18.2. Okay. So 18.2, preparing ethers. The Williamson method is on there. Know everything there is to know about that. You do the questions that are assigned to you on that. You should be okay. Okay. And look at the mechanism of how it works, because that will be important. Questions so far? So that's part 1 of question 3. Part 2 is going to basically be a conceptual question. It's going to see if you understand properties of chemicals. Okay. So I'll give you an example of a question that could be like that. It would be something similar. Okay. Let's say you have a mixture of an amide and an amine. Right, so you have, I'm not going to draw anything yet. So write this down. You have a mixture of amides and amines in a solution. And you want to be able to separate the two solutions. And you have access to essentially any acid or base that you want access to. How would you go around separating these two? The two molecules right now are water insoluble, so they're dissolved in naphthalene or something. Okay. So how would you go around separating the two? So any ideas?
If I have what?
So what would I do as step 1? Don't tell me how to do it. Just tell me what, or don't tell me the answer. Tell me what the steps I should take to answer this question.
What you have to separate?
Amides and amines.
You want to separate them, separate them by what?
Just be able to separate them. I have access to acids and bases, and I want to be able to separate them.
Draw the structure.
Good. Okay, guys, whenever you have a question, a conceptual question that has multiple things in it, draw those things so you can see what they are. So if I want to draw an amine, what does an amine look like? It's basically an R group attached to some sort of NH2 and NR, something like that, right? So that's an amine, okay? And don't forget to put in the lone pairs if there are any lone pairs. So So that's an amine. What about an amine? What does that look like?
Double bond.
So it's R, C, double bond O, and H2. That's the difference between the two, and you got a lone pair over here. Okay? After you draw the two molecules, you want to ask yourself another question is, what do I know about these two molecules? What are their chemical properties and what are their physical properties? Okay? So, in this case, the way they're drawn right now, is there really a big difference in their boiling points?
Yes.
Yes.
Is there? Why?
Double bond.
The double bond doesn't increase your boiling point. What is the biggest factor that increases your
Hydrogen bond.
Hydrogen bond. Right now, the way they are, both of them form hydrogen bonds. So the boiling points are probably not big enough that I can use that on its own to differentiate. So forget about physical properties. Let's think about chemical properties. What do we know about amines versus amines? What do we know about amines? What are amines? What can you use them as? What do they react with?
They are bases.
They're bases. Good. So they react as bases. Remember, like amines are essentially the organic component, the organic equivalent of ammonia. Right? Ammonia is a base.
Acid?
Yeah. So what does ammonia react with? It reacts with an acid. What happens when you react ammonia with HCl?
Salt and
Salt.
You get what's specifically you get?
Na.
Yeah, you get NH4 plus, right? Cl,
Plus H2O.
right? This is basically what you get. You get ammonium chloride, right? So let's put it this way to be sure. So this is a salt, okay? So what would happen if I reacted the ammonia with HCl? Good, right? So you get also a salt, okay? So before, water insoluble, right? Because this R group is big. It doesn't allow it to dissolve in water. But whenever you have a salt, salts are very soluble in water. So I just took this from being insoluble in water to make it soluble in water. What happens to this guy when I react it with acid? Is this a base? Does this work as a base?
no polar.
Why doesn't it work as a base?
Because there's the
Current direct electrons.
Yeah, like basically, you have a resonance structure. So if you remember from our chapter on amines, amides do not react with acids. Amines do. So this guy won't react. It'll stay exactly the same way it is, okay? And it will stay water insoluble. So now through this, you basically made one thing water soluble, one thing non-water soluble. So now you can separate them. Now that I have this, once I have this separated, how can I convert this back into this?
That was
base. Yes, with base.
What kind of base?
strong oil.
A stronger base. It has to be a base that's stronger, right? So what's a stronger base than an
NaOH.
Yeah, NaOH. If I react this with NaOH, what do I get? I get my original thing back, right? And I get NaCl plus H2O, right? So that's what I'm going to get. So if I had a mixture of amides and amines and I wanted to separate them, step one would be to mix that mixture that I have, mix it with aqueous hydrochloric acid, right? That will basically cause my amine to become water soluble and my amide, nothing happens to it. So now that I have water and naphthalene, I can easily separate the two. If you just let them sit on your beaker, or let them sit in a beaker, they'll come apart based on density, because one is polar, one isn't, so they can't dissolve together. I can separate those two solutions, and then I can get my amine back by reacting the salt with sodium hydroxide, and I get my amine back in. It'll be insoluble.
The first is the strong acid.
First is a strong acid, or any acid really.
Any
It could be, yeah, because amine's a weak base, but it's a strong enough base that it will react with all sorts of acids.
Add acid.
Then separate the.
Yeah, add acid to make it water soluble, separate it,
salt.
add base to bring back my original molecule. Okay, so you can use this kind of logic on everything, guys. So this is something you should,
So
as you move forward, like forget about this course. Okay, this course, I want you guys to take something away from this. If you're gonna take anything away from this course, know that when you guys work on separation problems in the future, always find out what's in your mixture. So find out what the components of your mixture is, and then start grouping them according to properties, physical properties or chemical properties, right? So let's say I have 20 things in my solution and I'm only interested in one thing. I gotta look at what's there. Can I split it up into 2 groups or 3 groups based on properties? If I can, then I can then apply a separation technology, and then I get a mixture that has now, instead of 20 things, maybe 8 things. Then I can look at those 8 things and figure out what's different about them and use another separation technology, and so on and so forth. And eventually you should be able to distill what you want, get what you want out of it. Apply this to everything, guys. It's logic. This is what I'm trying to teach you here, okay? So question 3 is going to have one of these logic problems. It's not going to be complicated with multiple things. It'll be only 2 things. It'll be a mixture of 2 things, and it's going to ask you, how do I separate those 2 things? So the first thing you should do is, you don't have to necessarily draw what the 2 things are. Just draw what you know about the groups, and then come up with a strategy, okay? And the question will ask you to write down the steps, what you would do, and the reaction. So you should be able to do something like this, where you would get a salt, for example, or whatever, okay? So kind of walk through what you're doing. Say again? This is still chapter, what section? That's everything. Well, this one's chapter 18, but the question on the exam could be from any of the molecules that we learned about. You should know the properties of that. So look at your different functional groups and just know the properties. Which ones are acids, which ones are bases, which ones are non-reactive. So what's an example of a non-reactive functional group?
Aromatic.
Okay. What else? So what about this? So what is that functional group?
Ether?
That's an ether. Are ethers reactive? No, ethers are not. They're not reactive. That's why we use them as solvents, because they're not reactive. Okay, so guys, I can't help you with that. You should just know a little bit about. You should know. Hopefully, by the time you leave here, you should know a little bit about different. Not like everything there is to know. Not experts on it, but a little bit. If someone asks you something about what's the difference between ethers and sulfides? Ethers are non-reactive, sulfides are. So if I wanted to separate an ether from a sulfide, what can I do?
React them together. React something.
Yeah, so what does sulfide react with? Just off the top of your head, something in sulfide.
Anything positive.
Okay, so give me an example. Like ammonia? What? Okay. Yeah, that one would be good. All right. You know what? Don't worry about it. Look at the chapter on sulfides, and you'll see. So for example, you can, if you react sulfides with hydrogen peroxide, you can get sulfoxides. You can get, so this, right, becomes this, right? You get that instead of if you reacted with hydrogen peroxide, for example. Okay. So these are ways you can basically differentiate, separate them out. What else did I say? You can also react them together forming disulfide bonds, for example. But anyways. Okay. So yeah, so part 2, question 3 is going to be some sort of separation question. Part 3 is going to be basically, part 3 is going to be, it's going to test your ability to draw a mechanism of reaction. So it's going to tell you step by step, you have a reaction, it's going to tell you step by step, it's going to be 3 steps or 4 steps, I forget exactly how, I'm going to tell you right now. But it'll tell you the steps of a reaction, the mechanisms. It'll be very specific on what these steps are. And you are supposed to take that writing and convert it into a mechanism. Draw the mechanism that they're describing. So use proper arrow notation. Show where the lone pairs are, where they're going, which bonds are breaking, which bonds are forming, that kind of stuff. Okay. And that's it. So that's all there is. So there's no memorization involved in that. Just know from chapter 6 if you want to know specifically. So chapter 6 has the arrow notation. Just know how to do that. Okay.
I saw.
Part 3, part 3.
Yeah, this is 3 part 3. Okay. So right now we did 25% plus 20% is 55, and another 20 is, so that's 75% of your exam done. Question 4. Question 3 is worth 20. So it's like 8. It's 8 marks for the first one, 4 marks for the second one, and then 8 marks for the last one. ايش هو؟ السؤال الثاني ما بتقدر تحصل نفسه بس لازم يعني من دراستك يعني اعرف الفرج chapter اي chapter كان عندنا functional groups chapter 3 yeah so for each of those functional تفرج عن functional groups اللي عندنا and just know something about it. You know, do they have high boiling points? Do they react with certain things? Do they act as acids or bases? Yeah, so know what the differences in their boiling points are, in case that's one thing. That's physical property. The other thing you can look at is, are they acids or bases? And if they're acids or bases, what acids or bases are they? If they're an acid, they're going to react with the base. Do they react with all bases? So I'll give you an example. Alcohols versus carboxylic acids. Okay? So how can you separate those two? Alcohol versus, guys, here's so someone wanted another example. I'll give you another example of that. Is let's say you have an alcohol and a carboxylic acid. Okay? Alcohol and carboxylic acid. So step 1, draw what the two things are. Right? So one of them is going to be an alcohol. The carboxylic acid is going to look like this. Right? So those are my two molecules. So what do you guys know about these?
Acid and
Bases. Bases.
Acid base.
This one is a base. It's called the carboxylic acid. Okay, so this one acts as an acid. What about this one? Can this act as an acid? Yeah. It can act as both, right? So alcohols can be acids and bases, okay? Are they strong acids? Which of these is a stronger acid?
Second.
This is a stronger acid, right? What about this guy? Is it a strong acid? It's a weak acid. What if I mix them with, so these are acids, what do I want to mix them with? So what kind of base do I want to mix it with? Give me an example of a weak base. NH3, sure. You can use NH3. If I reacted with NH3, what would happen?
Salt and water.
Well, what would, so this is the mixture. What would happen to each of
Okay,
these?
mixture.
So let's look at the top one. What would happen to the top one?
With a weak base would not react.
It would not react. What if I use sodium hydroxide?
Strong base?
Would it react with this guy?
Yes.
Does it?
No.
What is the only way you can strip that hydrogen off an alcohol? You have to use really strong bases. Give me an example of a really strong base. Nope. Sodium hydride. Okay. Only a hydride can strip the hydrogen off of this oxygen. Okay. Hey? Yeah. Oh, much stronger. It's a much stronger base. If you look at the pK, so look at the pK of the conjugate acid of this would be. You're forming OH1. So if you look at those ions, this is a much stronger nucleophile than this. Okay, so guys, you should know this. We've talked about this so many times in class. Alcohols do not react with sodium hydroxide. Okay? They only react with sodium hydride. If it was a phenol, if it would look like this, so that's a phenol. Okay, right? So a phenol would react with sodium hydroxide, but an alcohol wouldn't. This is a stronger acid than this. Okay? So alcohols are not going to react with sodium hydroxide. Will a carboxylic acid react with sodium hydroxide?
Yes.
what would you get? So the alcohol will stay the same.
C with Na and
What happens here? What am I gonna get?
Na.
Right? Right? So you're gonna form a salt, right? And then you'll get, if you use ammonia, you'll get NH4+. If you use sodium hydroxide, well, here you would get, if you use ammonia, you would get NH4+ like that. This would be the ammonium ion that forms the salt with this guy. So it would be like, you know, carboxyl, ammonium, whatever the carboxyl thing is, like whatever. So let's say this was CH3 here. So this would have been originally ethanoic acid. So it would be like ammonium ethanoyl, you know, or something like that. You'd have to name it, don't worry about that. But if we use NaOH, so let's stick with NaOH because it's easier to use. You'd get that, and then what else would you get?
H2O.
Yeah, you get H2O. Sure. So now you have this thing, which is soluble in water, and you have this thing, which is this soluble in water or not? Let's say here you had, yeah, so let's say it was a big alcohol, it's not soluble in water, right? So you can separate them using the same kind of, see what I mean? Like, so, yeah, so, know these ones and you'll
Steps.
yeah, so step one is this. React with sodium hydroxide, aqueous sodium hydroxide. Separate, step two is separate the two, because one is water soluble, one isn't. Step three is you want to convert this back into the carboxylic acid. So what do you do?
Reacted with
Yeah, someone said it. What is it?
Strong
No.
That's it.
Yeah, so I reacted it with a strong base to make this. If I reacted with a strong acid,
You will revert it.
I'll reverse it, right? So I'll get this, right? Plus, what do I get? So this Na got removed.
Salt.
I get salt. Table salt, right? So then I can get my original compound back. Okay? And it's very easy to separate salt from anything else because you can use permeable membranes that are small enough for that. Okay. So that's it for question 3. Let's go into question 4. Question 4 has a lot to do with aromaticity. So it's again chapter 16 and the rules of aromaticity. So let's go over those rules and talk about how do you determine if a molecule is aromatic. So what are the rules for aromaticity? What's rule number 1? Aromaticity.
SP2.
Rule number 1.
Carbons has to be SP2.
Yeah, so what's another way of saying that? So you want planar ring. So it's got to be a planar ring. What else does it have to be? You guys really did not study this at all. You guys remember conjugated? What does conjugated mean?
Later.
Conjugated means, yeah, conjugated means you have basically electrons that can go around the whole ring. All the members of the ring are conjugated. Okay? What's number 3? One of the most important ones. So, is this aromatic?
No.
Why is it not aromatic?
Should be
It's planar, it's a ring, and it's conjugated.
Something
الألكحول.
N2N or something.
So what do we call that rule?
Number of
Remember Huckel's rule? 4n plus 2. Specifically what? 4n plus 2 pi electrons. So these have to be electrons that are in p orbitals. Yes. N is any integer. 0, 1, 2, 3, 4. Plug in any integer for here. So and n is an integer. So plug in 0. If you put 0, that means 2 is one possible answer. 1 would be 6. 2 would be 10. So on and so forth. So these are the possible numbers.
نعم جاي
6, 10.
جاي يكون عندك
ايش هو؟
الأخيرة كيف نطبقها على الشكل؟
2 6
ما طبقها. Look at this. How many pi electrons do we have here?
How many electrons?
Pi electrons. No? Pi electrons.
6.
Yeah. 2 here, 2 here, and 2 here. So here I have 6, right? So 6 is one of those possibilities. Okay, so if we look at this guy is planar and ring. It's conjugated, and it follows Huckel's rule. So this is aromatic, right? This guy is planar. It's a ring, and it's conjugated, but it doesn't follow Huckel's rule. We call this anti-aromatic. Okay? Anti-aromatic. And there's one more that you don't want to mess up is, let's look at this guy over here. So 1, 2, I'm terrible at drawing the structure, so bear with me. 1, 2, 3, 4, 5, 6, 7. Okay. So here's a 7-sided ring. I'm going to put.
It's not conjugated.
Okay. So here's another example, guys. Pay attention here, okay? So this is a ring. No problem. Is it planar or conjugated?
Not
Why is it not planar?
not
What is the reason it's not
not one
planar?
of them are sp2.
Yeah, this one here is sp3, so it's going to be tetrahedral, and it's not conjugated anyway, right? So this ring stops here. There's no p orbitals here. Here you don't have p orbitals, so the electrons can't go around the whole thing. So when you have something that doesn't obey one of the first 2 rules, we call this non-aromatic.
Anti-aromatic and non-aromatic.
They're different, okay? So this question number 4 is going to ask you about the rules. Know the rules of conjugation, or rules of conjugation, the rules of aromaticity, and then you're going to get 4 structures, and they're going to ask you which of these are aromatic, non-aromatic, and anti-aromatic. And why are they that?
All of them or only one?
Anti-aromatic means they obey the first 2 rules. So let's look at this, right? So this is a ring. Guys, this is a ring. It's planar. It's conjugated. So there's p orbitals everywhere. But if you look at the number of pi electrons, we have 4. And 4 is not one of the possible answers. So this thing just doesn't obey Huckel's rule. So that's the only thing that's wrong with it. So it's anti-aromatic.
Why you put n equals 0, n equals n equals?
That's just the rule. You just plug in all the possible integers. So you can also be 14. Right? You can also be 4 times 4, 16, or 18. Okay? So those are the possible numbers that are there. So just plug in any integer for n to see if you get the right answer. Okay? And n can be any integer. حط أي integer في n وشوف الأرقام اللي تطلع. يعني إذا حطيت n equals 0, 2, n equals 1, 6, n equals 2, 10, n equals 3, 14, n equals 4, 18, and so on and so forth. So those are the possible numbers. And then you just want to look to see your structure. Does it have one of those possible numbers? If yes, you should use this rule, guys. So let's look at a complicated example.
الأول والثاني غلط. أنتي؟ نعم؟ إذا الأول والثاني غلط.
Is that aromatic?
أوكي بس الأول والثاني غلط.
Right now it isn't. Why is it not aromatic right now? What if I did this?
الأنتي الأول والثاني صح؟
Okay, connected something else.
And what if this carbon is a carbocation? What's the hybridization of a carbocation? This becomes an sp2 molecule. It has an empty p orbital, right? So is it a ring? Yes. Is it conjugated? Conjugated means yes, it is.
Yes, it is.
Conjugated means there are p orbitals on every single member of the ring.
Yes.
Conjugated means it has p orbitals available. P orbitals. So that means it has to be sp2 or sp3. sp2 or sp hybridized. It has to have p orbitals because the p orbitals are where you get. Okay, so is everything sp2? If yes, then that means it's conjugated. Okay. How many electrons in the pi orbital system does it have?
3.
It's 2. Just the double bond here. This one doesn't have anything.
So it's aromatic?
It's got empty. So
Oh,
this
okay.
is aromatic. Remember, aromatic can also apply to cations and anions. Remember from the lecture we did?
Yeah,
It
yeah.
doesn't have to be a neutral molecule. It can be positive or negative. Okay. So that's the answer to your question. That's the simplest aromatic molecule you can have. It doesn't get any simpler than that.
Non-aromatic does not obey one.
Non-aromatic is not either a ring or conjugated.
One.
If it obeys all the rules except for Huckel's rule, then it's anti-aromatic. Okay, so know those differences. Let's look at a more complicated example. Let's look at, here's one where you have, let's say, carbon. Why is this like? Why do these pens just last for one question before they go?
It's the end of the semester.
Let's try something else.
بس تعرف وين موجود؟ بعرف. اوكي
Try and remember the structure of my
ما صار عادي. شوف مال النيتروجين ما يتحرك. ما يدري شنو هو. لا. زي عاد كنا نقدر نسميه ولا؟ شوف الأسامي كان يسوي عليها إكس. عرفت؟
So would this molecule be aromatic or not? Guys, look at this molecule here. Would it be aromatic?
Yes.
Yeah. Why is it aromatic?
It is a ring,
Yeah.
planar ring,
Conjugated.
conjugated, and the 6.
Yeah. So the atoms don't have to be carbon. They can also be nitrogen. Okay. They can be other things. I'm trying to find the more. Get the structure.
لا اللون بير بهذه الحالة إلا النيتروجين ما يتحركوا بين ما يصير زي فاتكين.
Guys, what about this?
هذا وين؟
What about this? Is this aromatic or not?
No, because the
Let's think about it.
sp3.
Okay, so let's look at. So is it a ring? Yes. Is everything sp2 hybridized?
No.
What would happen if the nitrogen was sp2 hybridized? So right now the way it is, we only have 4 electrons, right? That are part of this thing. There is one way where this thing could be aromatic. What would it be? No, we're not gonna make it an anion or cation. Just the way it's drawn, it can be aromatic. How can I do that?
Make a double bond?
No double bonds. I'm not gonna add any bonds. What happens if this thing is sp2 hybridized? If it's sp2 hybridized, it means it has 3 sp2 orbitals and 1 p orbital. Right? So this is an sp2 orbital here, right? This is an sp2 orbital over here, and this is an sp2 orbital over here. What if this lone pair was actually in a p orbital? So what if it was a p orbital and I had 2 electrons on it? Okay. Oh, hang on a second, that really messes things up because this carbon throws it up. Never mind, I didn't see that. That's a bad one. I'm trying to give you one where it works. With 5 carbons it would. Let's do 5 carbons.
ارسم الشرف عبد الله بيخلص الكرات.
Okay. Now we're okay. What about now? Is it sp2? I mean, is it aromatic or not? Why is it aromatic? So this is definitely sp2. This is definitely sp2. This is definitely sp2, and this is definitely sp2. Can this be sp2?
Yes.
Yeah, it can be, right? So if it's sp2, this is one sp2 orbital. Here's another sp2 orbital. Here's a third one. And this guy can be in a p orbital, right? So this guy will donate 2 electrons to the p orbital. Here's 2, yeah. And here's 3, so we got 6. So we have 6 electrons in the p orbital.
But Doctor, how can we know that electrons in the...
So yeah, so that's the question. Okay, so if you look at again chapter 15 and 16. Let's look at chapter 15 and 16 again. Let's go back to aromaticity. Guys, no aromaticity. So where do we look at pyro and stuff? Yeah. So guys, remember this, okay? So this is a straightforward example. These nitrogens, we know that they're sp2 hybridized, no problem, right? See these lone pairs, in this case you have a lone pair here and lone pair here. These guys are in an sp2 orbital, so they're localized, right? But you could have a situation where you have, such as in pyro, right? So here's pyro, which is basically different than the molecule you're there, but similar. This nitrogen over here looks like it's sp3 hybridized. Okay? If this thing is sp3 hybridized, this molecule is not aromatic. But if it's sp2 hybridized, then it is aromatic. Why? Because these 2 electrons become part of the pi system, right? So remember a big idea number 2 in this course. Big idea number 1 is everything's based on structure. Big idea number 2 is sorry about that, guys. Big idea number 2 is that everything in nature is always going to go towards a lower energy, okay? And aromaticity is a very stable structure. It's very low in energy. So if you have a situation like this, this nitrogen could rehybridize. So this nitrogen could rehybridize, become sp2. The lone pair will exist in a p orbital, and then this molecule obeys Huckel's rule, and it becomes aromatic. So in nature, that nitrogen will rehybridize to lower its energy level, become more stable, okay? Does that make sense? So if you read the rules on aromaticity, you can see that sometimes what looks like an sp3 atom can actually be sp2 hybridized because it would obey Huckel's rule. The question someone asked me is, how do I know when and when? Look at both situations. If one situation results in aromaticity and one doesn't, the aromaticity is the answer, okay? So when you have something like this, imagine, so when you have something like this, here, let's get rid of all this other crap on this side. So here's my nitrogen, and it's got a hydrogen on it. Imagine both scenarios. So in one scenario, this thing is sp3 hybridized, it's not aromatic, right? And this lone pair is in an sp3 orbital. It's stuck over this molecule, it's not moving anywhere. So it's a localized lone pair. And then imagine the other situation. In the other situation, this thing could be sp2 hybridized, and this would be in an p orbital, where it's delocalized. It's shared with the other members of the ring. And if I do that, then I have 2, 4, 6 electrons that are part of the ring. Why is this one not part of the ring?
Localized.
It's already in an sp2 orbital, right? There's an sp2 orbital here, an sp2 orbital here, another sp2 orbital here. The p orbital for this nitrogen is right here. It's a double bond, okay? So you know this is not going anywhere, this is stuck. This guy can either be localized or delocalized. So we got to figure it out. If making it delocalized makes the molecule aromatic, it's going to be delocalized. Because aromaticity is a very stable configuration. Yeah? So nature will always go towards that. So anyways, so that's question 4. Basically, you're going to have some aromaticity problems to deal with. finally, last question, and then I'm going to let you guys go. Is it looks like they look like multiple choice questions, but they're not. So quiz number 4 that I gave you guys, for the guys who didn't pick it up, it's right here. Pick it up at the end of class. Study SN1 and SN2 reactions again. Okay. Which ones are better substrates? Which ones are better nucleophiles? That kind of thing. That's pretty much it. Oh, and you're going to have a question on what has the highest boiling point. So if I had things available in front of me, what's the first thing you want to look like? Hydrogen bond. If something has hydrogen bonds in it, it's going to have the highest boiling point. What if I had two things that can do? What if I had two molecules that could have hydrogen bonds, but I wanted to know which one? Molar mass is number 2. What else?
Dispersion force.
Sure, structure. So what if I had this? What if I had an alcohol versus, and let's say the length of these are the same, versus a carboxylic acid?
Second.
Why this one?
Has more molar mass.
Because molar mass, it's not enough to make a big difference. Yeah, do you remember?
Area.
You remember if you have 2 of these, so 2 of these carboxylic acids can form a dimer. Like you would get a hydrogen bond here and a hydrogen bond there. So 2 of them can come together and form a double hydrogen bond. You see that? The double bond O from this guy will form a hydrogen bond with an H from the other guy, and the double bond O from this guy will form a hydrogen bond with this H. So they form this like these dimers. Dimer means 2 of the same thing, and those things are held together tightly because it's not like with alcohols. It's just this, right? So there's a bond there. So they're only held together with one interaction, right? This guy here would maybe be held with another guy over here. You see that? Like they form like kind of single interactions. If you rip this apart, they come apart. Here you got to rip 2 of the same. You got to rip 2 hydrogen bonds apart to basically get them away. So yeah. So I pretty much gave you the answer to one of the questions on that. If you have to basically pick between an alcohol and a carboxylic acid, you should know carboxylic acid to have higher melting points, higher boiling points. Also. Last question I'm going to ask you is something we didn't really cover, but for some reason Ibrahim must have covered it in his class. Is we always talk about solvents that we use in the laboratory, okay? And if you guys notice, like benzene it's kind of a solvent that that's non-polar. You would think that we would use it all the time as a solvent, but if you notice in any of your chemistry labs, did you guys use benzene at all?
No.
Yeah. Why wouldn't you use benzene? Why is benzene a bad solvent? It's a good solvent, it's non-polar, but why is it a bad solvent? A lot of things are flammable. Toxic, yeah, so exactly, it's toxic, yeah. So benzene is very toxic. It actually causes leukemia, like in people, okay? So just know kind of that. For your final exam, you might get something to ask about that, okay? It's only worth 1 mark, so. Just know that benzene causes leukemia or cancer, if you don't remember leukemia. Yeah, toxicity. It's toxic to your health. It causes cancer. That's why we don't use it in the laboratory. Or if you have to use it, you have to really justify using it. And that's it, guys. That's pretty much it.
So Doctor, we study what we
You should study everything, and then look at what I just taught you, and focus on what I taught you. You should pass. You will at least pass the exam.